Good afternoon and welcome to this training session on TLX BatSafe, primarily focused for ecologists and architects. In this session, we're going to talk through the history of TLX BatSafe, some of the research and development that's gone into the product and the testing. We're also going to talk about specifically around the snagging propensity to test, the environmental impact of using this product versus others, and the difference between 1F felt and breathable membranes in buildings. In 1997, TLX insulation, then known as Web Dynamics, invented the three-layer breather membrane, which has been adopted across Europe as the standard breather membrane used in pitch roof applications. 2014, TLX was first made aware of the issue around breather membranes and snagging of the spunbond outer layer. This was by PhD researcher Stacey Waring, who actually brought this to light to us at our factory. In between 2014 and 2017, TLX funded the initial research Stacey did in this area, which included looking at mesh to stop fluffing plus coating. So it was quite a long, prolonged research and development phase we went into there to look at various ways to improve breather membrane suitability, but also solve the problem of snagging. 2017, 2018, TLX then really started around the R&D phase in full earnest. So we tested a very large variety of nets and coating types on membranes. And we also, in that initial research phase, did a 4 to 5 month live trial at the Isle of Wight Bat Hospital with various samples to test in situ with real life bats, obviously hanging off different scenarios and fabrics that we had just to work out what was best and most suitable to stop the snagging. 2018, the Bat Conservation Trust were brought in together with the steering group, which involved Natural England, Natural Scotland, Natural Wales, alongside two experts at Reading University to look at this area and primarily to look at a way of testing breather membranes in a lab scenarios to see if they were suitable to go into situ with bats. 2018 to 2020 was spent developing a way to test membranes of fluffing when bats made contact with them. This was primarily done by the steering group, led by, as I say, the industry, the national bodies of Scotland, Wales, and the UK. Bat Conservation Trust was chairing it, and Reading University was offering expert advice into ways to solve this issue around testing. 2020, the pilling test white paper was released outlining the full process and test procedures. So this is a document that is available online. It's a 28-page document that gives the full research paper and findings, and actually outlines the pilling test itself and how to test breather membranes for their suitability when for use when bats are present. 2021, TLX Insulation was asked to join the steering group at this point to sit alongside the members to advise technically on this area. And it was also when TLX BatSafe, our product, was submitted into the pilling test for testing, and it passed in 2021. 2022, we officially launched TLX BatSafe onto the market. So it was an incredibly long period of time from when we first were made aware of the issue in 2014 to 2022 in terms of getting this product to market. But there was a tremendous amount of research, development, and testing, both in live situations and developing a serious lab test to solve this issue that was undertaken over many years by us and the steering group. To go a little bit into the training now, so most of the people who listen to this are ecologists, obviously are more than aware of these issues. But if you're an architect, then it's probably worth you being reminded that a mitigation license is required for roofing repairs, loft conversions, demolitions, tree work, lighting installations. If there are bats present, you really have to consult your local ecologist for suitability for continuing work, or what mitigations might need to be taken, and apply for a mitigation license. The Wildlife Act and Country Act of 1981, it's illegal to disturb, injure or kill bats, um, protects bat roosts from damage or destruction. So it is a legal requirements. Conservation Habitat Regulations 2017 implements EU Habitat Directive, requires mitigation license for activities impacting bats. So you do have to apply for a specific license, and we always recommend contacting your local ecologist, or Natural England, Scotland or Wales, or if you want advice, Bat Conservation Trust is also a good place to go to as well in terms of looking for advice on this area. Why was the test done? Legal protection. All UK bat species, as we know, and their roosts are protected legally under the Wildlife and Country Act and Habitat regulations. So you have to do everything possible to protect bats when you're doing construction and building work, which is critically important. Emerging risk. It was made aware, obviously, in 2014 that modding roofing membranes, which bat can snag and claw. So what was really found was that breathable membranes are made of three different layers. You have spun-bond outer layers, and it's sandwiching a film that is the breathable and waterproof elements. The spun-bond outer layers are polypropylene, and they can become loosened, and the fibers can be pulled out of that structure. They fluff, they form loops, and they entangle bat claws. And that was really the issue that was brought to us and found. The consequences are fatal. That when bats do get caught in breathing membranes, they do die. So, there was evidence in a number of projects that this was found. Um, and there was a knowledge gap. There was no standard existed to assess snagging risk, leaving ecologists and builders without clear guidance. So it was sort of known in the industry that breathers were not really suitable for bats, but actually there was no standard set or testing or anything that had been done in that area to formalize it, as well, which is really the investment that TLX put in, from the early days. The goal is to develop a reliable laboratory method to replicate bat claw interactions and identify safer roofing materials for conservation and compliance. So the goal of the testing and the steering group really is to develop a lab test that truly replicates bat claws on breathing membranes, and that test can then be rolled out as a way of gatekeeping any breathing membrane going into the market to make sure it's suitable for use. The snagging propensity test for roofing membranes is, as I say, a live document. It's online. It can be read. The problem addressed: many roofing membranes pose threats to bats, which we've just discussed. And I think the other problem that we've seen as well is that bat interacting with breathing membranes, especially when they're coated membranes, the urine can also degrade the coating massively and have a huge impact on its integrity and also its ability to fluff. So there are two main areas that we saw bats, claws and urine being a major one. The new test method developed, research scientists alongside the SNCBs created a modified pilling test method using Velcro, which we're going to go into in a minute, strips to simulate bat claws and measure the snagging risk of various membranes. So we'll talk through a test in a minute in terms of what it actually is, but it is a pilling box method. Materials tested: there were 4 types of roofing membranes tested. 3 were breathable, non-woven, and 1 was an impermeable membrane, which is a non-breathable membrane, which most of the people listening to this would think of as 1F felt. We were evaluated for loop formation and surface degradation. 2 important points. We are looking for 1 single loop in the test, no more. That is a fail if you get single loop. And degradation is around what is the state of the outer layers or the membrane itself when it comes out of the pinning box. Loop formation as a risk factor. The number of filament loops per centimeter squared was used to quantify snagging risk. Higher loop counts indicate greater danger to bats. So as I say, 1 loop is a fail in the test, and it's measured in centimeters squared. Why test membranes for safety? The main point here is testing helps identify safe materials and support conservation, and that's really what we're trying to do. Is develop a test that truly um, qualifies product to go into areas where bats are present, and actually weeds out the ones that aren't suitable and are danger. Simulating bat claw snagging on a roofing membrane. So on the right, you'll see two images. One is the snagging propensity text box. There are Velcro strips on the inside, as you can see. And then we wound different samples of breather membrane, or Reading University does, around a core to go into that box. So that, in its simplest form, is the method, and that pilling test box is standard material kit. You can look at it online in terms of further information. Velcro strips on the inside, as we said. The membranes are rotated 1,000 cycles, so the 1,000 rotations of that box, and they're rotated at 60 repetitions per minute. Loop formation inspected visually and microscopically, which is very important. So there's a quick visual inspection, and then obviously we go into microscopic inspection to look for loops. Snagging risk results across membrane types. So non-woven membrane shows significant loop formation. I'm going to show you a slide next in terms of what that means, but pretty much every breather membrane that we put into a pilling test failed. It formed loops and it failed. Non-polypropylene roofing membranes had zero loops. So if you look at something like bitumen 1F felt, there are zero loops formed with that type of product. Loop density is measured in centimeters squared, as we said earlier. A pass criteria. So on the right, there are two images. Those are swab samples on the right that are cut out, and then they're microscopically inspected and also visually inspected. And then there's a microscopic image there, obviously, of the Velcro claws pulling away or pulling out the polypropylene fibers, which is the key thing we wanted to replicate. And as you can see, it really is a great simulation of a bat claw, and that process of just tugging away and creating fluff. Membranes must show zero loops after 1,000 rotations, as we've said. So it is quite a stringent and strict test. It is zero loops, not one. Visual and microscopic inspection confirms safety, supports legal compliance and bat conservation. Okay, so breathable membranes failed on average at 250 rotations of the pilling box. And if you think 1,000 rotations required for a pass, that is the average that we saw, and on a lot of occasions it was far less than that. TLX BatSafe showed no fluffing after 75,000 rotations. At that point, we had to abort the test because there was zero fluffing, even at that extreme amount of time and rotations that we put it through. Given that it's 1,000 rotations for a pass, we felt that it was quite a strong position the product at that point around the pilling test. This is a pass certificate, so this is the certificate you should look for. It's available on our website, that it has gone through the snagging propensity test and it's passed, it's got a date, etc. So this is obviously a live document that we have on our website, and this is what you should be looking for in the market if you're looking at breather membranes in roofs. Hasten to add on this, sorry, that the other point here is that the product also needs to be passed by the steering group themselves for suitability, because there are other aspects that I've mentioned specifically around urine degradation of coated membranes, which is very important to consider because that is another area that also should be looked at. Bitumen 1F felt. So bitumen, it has been the incumbent. It has been the product that has typically been recommended when bats are in the local area, but it has some very serious drawbacks in terms of the environment and builders in general, which is important for people, ecologists and architects to understand. So a breather membrane, and its core characteristic is not breathable. It's a non-breathable product. And what does that mean? It prevents proper insulation, leaving colder buildings with insufficient and unable to meet modern energy standards. And I'll explain why in a minute. It does raise condensation issues because it isn't a breathable product. So it very much relies at that point on the installer doing a very tight and correct install, and also the right products and ventilation being used around it to make sure there isn't a condensation risk in the building. It can reduce thermal efficiency by 87%, and I'll go through why in a minute, but it does have a dramatic impact on the ability for properties in the UK to be fully insulated and to meet their carbon emission targets. Degrades over time. As you can see from the image on the right, over time in a roof, a bitumen felt will degrade, and and that is one of the major issues with it. Alongside, one of the issues with these types of products is the weight and the difficulty to install for the roofer. So all roofers will typically want to use a breather membrane for handling purposes. Architects and homeowners, etc., want to use a breather membrane for its thermal insulation properties and the way the roof is built, which I'll explain to you in a sec. It's extremely heavy and hard to handle, as I've just said. So bitumen 1F felt, this is a cross section of a roof, and I wanted to talk you through the differences here. So when you install a non-breathable product into a pitch roof, you have to leave a 50mm ventilated air gap underneath the membrane to vent away moisture. It's absolute requirement. You cannot do anything else. However, that air gap means you have a huge reduction in the amount of insulation you can put into the rafter. And the key area to insulate is always between those rafters. So there's an enormous loss in terms of the amount of insulation you can install when you specify bitumen 1F felt in a pitch roof. TLX BatSafe, the differences. It improves thermal performance versus bitumen by up to 87%. And that's a big number when you're looking at homeowners and you're looking at carbon. Reduces CO2 emissions by 57%, helping combat climate change. Obviously, it's a key topic that everyone is very focused on, and making sure properties across the UK are properly insulated is a core mandate. Full insulation is possible. TLX BatSafe allows full insulation up between the rafters I just shown without condensation risk, as it is fully breathable, which means older properties can finally be upgraded to modern standards. The only way typically you can improve insulation in old buildings, especially old roofs, is by using every bit of space possible because space is always very limited. And a breather membrane is typically the only way you can do that when you're looking to insulate between the rafters. It is approved for mitigation licenses. So TLX BatSafe is approved in Natural England, Scotland and Wales for licensing. TLX BatSafe roof. So this is the same cross section, but this is actually with TLX BatSafe rather than bitumen 1F felt in the roof. As you can see, because it's fully breathable, you can actually now fully fill the rafter with insulation. You don't have to have a 50mm air gap, which means that you can get a huge improvement in the thermal performance of that roof by swapping out TLX 1F for a breather membrane, or in this instance, because BATs are present, TLX BatSafe. This is just some diagrams showing the difference. So obviously you've got 87% TLX BatSafe is green in terms of thermal performance, and then with bitumen you've got a huge reduction in an average roof there in terms of the insulation you can fit in with shallow rafters. The CO2 emissions on average, these are done on averages, 10 tons of carbon can be emitted using bitumen in a bitumen roof, and you can reduce that to just over 4 tons per annum using a breather membrane TLX BatSafe with insulation fully filling the rafter, as we've said. And these are also both done on averages, so we're happy to supply how we've calculated those if people wish to ask. Last couple of slides. This, I wanted to talk you through a case study we've done. So BATS at Spring Hall case study is Heritage Meets Sustainability. On the right is the building and the roof. This, in roofing terms, is a complex roof. It's got lots of different angles and areas to it, dormers, and it's extremely old. And the issue with roofs like this is you're typically dealing with extremely shallow rafters. Maybe 75mm is quite common. So you have quite limited space to insulate. If you're insulating a new build development, then you typically have deeper rafters with more space to fill insulation. But in old properties, when you're re-roofing, you have very small amounts of space. The other thing when you're re-roofing in the UK is if you strip 50% or more of the tiles off the roof, you have to improve the insulation value of that roof. So it is a serious issue for architects to get around how to improve the thermal performance of something like that, but also re-roof it correctly. So it's Gothic Revival mansion built in 1871. It's very old, cathedral registered office. Previously, it was a World War I hospital, guest house, and it was a ballet studio apparently before that. Re-roofing requires insulation upgrade during a renovation. So as I said, you're going to re-roof that roof, you have to improve the thermal performance. You cannot leave it as is um, in terms of legally. The challenge, heat loss and bat safety. So two things. We're trying to get insulation between very shallow rafters, but we've been told to use bitumen 1F felt. It was physically impossible in this roof to do both. If you There were very shallow rafters I'm about to show you, so fitting bitumen 1F would have meant you had no chance of putting any insulation in that roof at all. So original roof U value was 3.87, so that is major heat loss, almost nothing in there whatsoever. Only 75 millimeter of rafter space under there. Lath and plaster ceiling reduced depth further, so it could have probably been about 65 millimeters of space you had underneath or in between those rafters to put any insulation in there whatsoever. Potential bat presence was in the area and been seen in the building before, and standard membranes were deemed unsafe. Sorry for this project. The solution: energy efficient conservation. They installed TLX BatSafe membrane across the entire roof. Allowed 30 millimeters of PIR board despite constraints. So PIR is a very highly effective insulation, and it allowed for 30 millimeters to go into the space there underneath, because they didn't have to allow for an air gap with the breathable elements of TLX BatSafe going in. Achieved a U value of 0.7, which was an 82% heat loss reduction. So there was enormous benefit to that building and property by swapping that just the membrane out and allowing to fully insulate, and also a huge carbon saving. It was obviously, it's been deemed completely safe for bats, the product, and it's compliant with conservation requirements. So all sides were happy. I won't go into full detail about this, but if you are asked by roofers or builders of how to install, this is a standard breathable membrane. It's installed in exactly the same way as any breathable membrane that's available on the market today. The installation instructions are on the website, go into every roll, so that's very simple. So in summary, TLX BatSafe improves thermal performance by up to 87% for the reasons we've outlined. Reduces CO2 emissions by 57% compared with bitumen 1F felt. Enables full insulation in old buildings. It's lightweight, strong, and easy to install, which is one of the critical things that roofers will always push for when they're going into projects, because they want their teams using materials that are of modern standards and good for them to use. It's breathable and it's waterproof, and it helps meet UK climate goals and building standards. So that is the end of the presentation there. Also, it's worth noting that on our website, you can go here and have a look at any of the things that I've just mentioned. So on the drop-down menu here, you can look at the snagging propensity test or the testing that we've done. And on the front page, there are various videos and other things that you can look at. If you wanted to, for example, see the snagging propensity test, you can follow this link. There are hyperlinks throughout the site, but if you click on that, you'll be able to see the full 28-page document. At the top here, it outlines who was involved from the various groups in terms of this paper, and then as you go down through the paper, you'll be able to read what research and development went into it, what the testing is, and what all the recommendations are as well. So that's all there on our website for viewing, and obviously the test certificate is also available on the site for if anyone wants to see it or show to a building contractor or ecologist. I hope that's helpful. And if you have any questions, there is also, our website has a technical hotline at the top there, and our email. So feel free to send us any emails or questions. We'll have to answer them as best we can. Thank you very much.